Audio Jungle. Audio Jungle.
Hello everybody. I'm here today to talk to you about a very interesting application that my company has been working on over the last few years. This has been quite a journey, but it's culminated with us solving one of the biggest problems that's there in simulations at the moment, which is the generation of pattern of life within simulations. Pattern of life, very simply put, is the vehicles, the traffic, the people that populate a simulation, that populate the 3D environment and help make it more realistic. And it should be done in a way that it's automated so that you don't have to spend hours and hours editing the scenario to make it much more realistic. And the solution that I'm going to explain to you today is how we used AI to solve different parts of a larger problem to achieve an automated solution for the generation of pattern of life. My company works on serious games. Just to explain to you what serious games are, you got games which have been around for the last 30, 40 years. And games have been primarily used for entertainment. They've evolved hugely over the last 30, 40 years, from the graphics to the interactivity and the amount of entertainment that they give to people. Simulations have been used for a long time within industry, and simulations are usually used to model a real-world sequence, something that happens in the real world, to do that in the computer so that you can analyze it, test it, come up with plans on what you're going to do with it. But what we do is basically a hybrid between the two, where we combine games and serious games, where we take the models and the realism of a simulation and combine it with the interactivity of games. The military especially has been using serious games for a long time. A lot of the top militaries around the world have used serious games for at least the last 15, 20 years. And they use it for a number of reasons. They use it for training, to train soldiers, to train officers on how to do things. They use it for evaluation, when they want to test soldiers, when they want to see if somebody's learned something properly. They use it for analysis. Once they've done a mission, they want to see if they've used the correct procedures, and they want to see if they could have done something better. And also they use it for what's called after-action review, which is after you've done an actual mission, you try to rerun it on a computer to see whether you could have done certain things in a better way. Just to give you an example and a snapshot of how this stuff is used, one of the primary ways that is used is inside simulation battle labs, which are just PC labs with lots of computers. You have platoons, squads of soldiers who come in and train together in a combined environment. Similarly, you have simulators which are used as part of larger hardware systems, where you got aircraft simulators, tank simulators, so on and so forth. More recently, more and more simulations are being used in full 180-degree or 360-degree domes or simulators, so that the soldiers can get the full immersive experience. They know what's going on all around them. And lately, they've also been used quite a lot within virtual reality systems, because that gives the soldiers a full immersive environment. They see everything that's going on around them. They know what's happening, and when you combine it with other smart tech, you get feelings, wind, everything around that. So the efficiency or the efficacy of a training environment using simulations is really based on how realistic that simulation environment is to what happens in the real world. If the simulator does not represent what happens in the real world, the training outcome or what the soldier would get out of the simulation is not what it should be. When the soldier goes into the real world, they're not going to be ready for that. The main way that we add realism to simulations is by, number one, obviously the terrain needs to be good. It's got to be representative. It's got to be the city that you're going to be training in. You've got to have good models. The models are the people, the vehicles, the trees, all the stuff which goes into it. You've got to have correct weather. It's got to be the correct time of day, the light. Everything's got to be similar to what happens in the real world. The mission, enemy soldiers, everything that happens within the environment has to be similar to what happens in the real world. But also, very importantly, especially if you are running a training exercise or a simulation within a city, a village, or somewhere that people populate, one of the most important things is to create the correct ambience or the life within the city to give the soldiers the full training experience. If there are people walking around the city, if there is cars driving around the city, if there are animals going all around, then you need that within the simulation. If not, what the soldier or what a trainee gets out of a simulator is not what they're going to see in the real world. The normal way that pattern of life is added to simulations is manually. If you have one person that you need to walk from one place to another place, the normal way it's done is you need to set manual waypoints and let the program know where this entry should be going throughout the lifetime of the program. And that, as you can imagine, if you have hundreds, thousands of people, hundreds, thousands of cars, it can take days and days and days just to get something realistic up and running. And that's where we come in. We've come up with an automated solution where, given a very few parameters, a few configurations, you can automatically generate pattern of life, which is representative of that particular environment that they'll be training in. So the method that we've come up with is based on 3 steps. The first one is terrain processing, entity planning, and the final step of pattern of life generation. That's what I'm going to walk you through today. So the first step is terrain input. Terrain input is basically where you get information about where the simulation is going to be running in. We usually get just a 3D mesh. We use our own intelligent algorithms, and we determine where there are roads, where there are crossings, where there are buildings, where the traffic lights should be. All that's automatically generated. And this is where we use a lot of search and matching algorithms to get to that point. After this step, we move on to what's called terrain annotation. And terrain annotation is really where we try to understand details about what's in that environment. We use open databases like OpenStreetMaps, Google Maps, and whenever possible, even data from land usage, road usage, traffic light planning, things like that, and enter that, and finally come up with an annotation on the terrain where we know exactly where the houses are, where the offices are, where the restaurants are, all that stuff. And now we know everything that we need to know about that particular terrain that we can use to generate a pattern of life. Next comes entity processing. Step 1 would obviously be understanding which types of entities we need. So obviously we need to know the demographics of the region where our simulation is running on, and we select the appropriate type of people. We select the appropriate type of vehicles, and whenever necessary, we also select the appropriate type of animals. Once we do that, we need to then decide what these entities are going to be doing within the simulation to create this pattern of life. And the way we define it is through a set of activities that we assign to every single entity. Now, activities within our system can be one of 3 things. They are what we call tasks, and a task is basically anything that an entity within the simulation can do. It can be buying coffee, can be going to a shop, it can be dropping your children off at school. It's just single activities that that entity would be doing. A lot of visual value to a pattern of life is how people actually get from A to B, which is movements. If somebody needs to go from home to office, how do they get there? Do they walk? Do they cycle? Do they use a car? Do they use public transport? If so, do they use a bus? Do they use a train? And that's all dependent on the area that they live in. Once you know which entities we are going to use, the next step is to do entity planning. And the outcome of an entity plan would be the pattern of life. So pattern of life always starts with a definition of the entities that we are going to be sending in. And every single entity that we have within our pattern of life has a set of properties. These properties could be type, age, sex, job, things like that, things which describe that particular entity. But more importantly, like I talked about earlier, are the activities, which are the things that that entity would do within this simulation environment. These activities, like I mentioned earlier, are tasks, reactions, and movements. But then the most important part is where we determine what type of movements this entity is going to be working on. For movement planning, what we've done is we've taken some historical mathematical models that are used within traffic forecasting, models that have been used for the last 30, 40 years to forecast traffic within cities. And we substituted our own methodologies into that to go through what's called a 4-step model to generate details on what mode of transport each one of our entities are going to be using to perform their movements. So once all this entity information is sent into the pattern of life, it's combined with the area data that we generated earlier. So very simply, the way our pattern of life engine works is that it takes input from a database and then also gets information from any simulator. It could be a VR system, it could be a simulator, any type of hardware-based simulator system. It gets certain scenario information, terrain information from the simulator to create these entities and control them in real time. Similarly, it also gets some information back from the simulator so it can react to events, things like explosions, aid trucks coming in, the stuff I mentioned earlier. But what the customer or the user of a pattern of life system finally sees is that they've got to be able to define a pattern of life in a way that's convenient to them, that's familiar to them. What we've done is we've defined a system where you can define your pattern of life using simple natural language. It's done in a way that it's non-terrain specific. It's not dependent on being a pattern of life for London and a pattern of life for Afghanistan. It should be the same pattern of life that works for both. It's configurable, simple parameters that can be changed back and forth, and it's also reusable. Any pattern of life that's created once can be reused over and over again. The first example I've got here is where we have 5,000 people coming into the city between 6 o'clock and 10 o'clock. That's all you define. And everything else that's needed before that is calculated by a system. It could be something a bit more complex, where you say 1,000 people coming to work at 8 o'clock. I want 400 people coming into a market to shop between 8 o'clock and 10 o'clock. And then we use natural language processing to understand these commands and then inject that into our pattern of life generator. One single AI system, it's a lot of different AI components that we use. But on a very, very high level, we use AI for terrain processing and annotation. It's simply a search problem. We use it for entity planning during the 4-step modeling process that we do. We do a lot of matching. We use gravitational models. We use it for path planning. We use simple A-star search for that. We use it for entity control, when the entities are getting from place to place, when they got to do collision avoidance, things like that, and also for reactions. So the culmination of all the work that we've been doing over the last few years is that we are currently in the process of leading an industry effort to define a standard for the definition of pattern of life for all simulator users. We've already finished this. We'll be publishing a paper in a few weeks' time. But we've come up with this standard with the industry, and it's basically a simplified standard where anybody can define a pattern of life using our XML standard in a way that it's reusable, portable, and also deterministic. So this is the outcome of everything that we've done. It's an application where you click, select the area that you want, tell the number of people you want, tell the number of vehicles you want, bang. You get people and vehicles walking right throughout your city. So what you just saw, the video that you just saw, is an application that we released several years ago, an application called Ambience. And Ambience is our internal automated pattern of life generation tool. Ambience is simulation platform agnostic. It works with any simulator around the world. It works on any type of terrain, any environment. It uses different types of data sources. It's reusable, adaptable, and portable. Thank you very much for listening.